Hello everyone, DaveDev here, and welcome to this video. In today's lesson, we will take a look at classes in PHP, as well as introducing one of the most commonly used design patterns called object-oriented programming. What is a class? A class is a user-defined data type that includes custom methods and properties inside. An instance of that defined class is usually called an object. What is object-oriented programming? Until now, we were writing code without having any kind of a structure or organization, which can make the code very hard to read, maintain, and understand on the long run. This kind of programming is also called procedural programming. That is where object-oriented programming comes into place, because the main goal is to add some structure and sense to the code, making it easy to understand, maintainable, and easy to debug, as well to allow the code to be reusable. To define a class, we just need to use the class keyword followed by the name of the class and then open and close curly brackets. In between the curly brackets, we will define the variables and methods that our class will have. The first thing that we will do is to define the properties of the class. It is very similar to defining a variable, but the main difference is that we have to define the accessibility keyword on the front of the declaration, which will define if the properties are accessible from outside of the class. And after that keyword, we will define the type of the property. This one is optional, as we can set an undefined type, and then PHP will choose appropriately when we use that property. And after that, we just define the name of the property. For methods, it's very similar to declaring a function outside of a class, with the main difference again that we have to define the accessibility keyword just in front of the function, which will define again if the method is accessible from outside of the class. And then for instantiating the class, we just need to declare a normal variable and then create a new instance of that class by using the new keyword followed by the name of the class and open and close brackets. And for accessing a property or a method of the class, we just use the name of the variable that we stored the class followed by the arrow symbol and then the name of the method or property that we want to access. Let's think of a real case scenario where we would have applied this design pattern. Let's imagine that we have a basket of fruits and we want to define each one of them in our program. We know that all things inside of the basket are fruits and they share properties between them, such as color and name. With this code design pattern, we can simply define a class fruit, which will have properties as variables inside of the class. And then we will create each instance of the class fruit with different values on those variables. An apple will have the red color and the name apple, and a banana will have the yellow color and the name banana. Now let's implement this example in code. The first thing that we need to do is to define the class fruit, just by using the class keyword followed by the name and open and close the curly brackets. In between the curly brackets, we will define the variables and methods that our class will have. In our case, we will define the color of the fruit as well as the name. You will also need to specify on the front of the variable if the variable can be accessed from outside the class or not. The public keyword means that the property can be accessed from outside of the class. On the other hand, the private keyword means that the property can only be accessed from inside of the class. And for creating an instance or an object of this class, we will need to use the new keyword followed by the class name and open and close the brackets. And for accessing the properties of the fruit class, we just use the arrow symbol followed by the name of the property. As you can see, we are assigning values, the name and the color property, and after that we are printing those values on the screen. As we said before, classes are composed by groups of properties as well as methods, which are functions that live inside of the class. To define a method, you just write it like you would do with writing a normal function, with the addition of the accessibility keywords, private or public, to specify if the method can be accessible from outside of the class or not. Let's change the accessibility of the class properties to be private and define two methods to get and set those variables. One thing to notice here is that in order to access the class properties from inside of the class method, we need to use the this keyword. This will tell to PHP that we are using a class variable instead of a normal variable. And then you can access these methods by using the arrow symbol the same way as with the properties of the class. Having these getter and setter functions is a good practice when writing classes, and it is something that you should be familiar with. There is some cases where we'll need to initialize the class properties at the moment it gets created. For example, to prevent errors when accessing class properties that are not initialized, or simply if we want to execute code to prepare the class object. This is what the constructor is for. It is basically a method that will get called automatically when creating an object instance of this class. The syntax is very similar to a normal function, however the name of the function must be called __construct. Notice the double underscore at the beginning of the function name. This function can have arguments the same way as any other function, and those arguments will need to be specified at the creation of the object instance. The same way as the construct, we have the exact opposite case, the destructor, a method that gets called when the object is about to get destroyed, either by a manual destruction by the user code, the code going out of scope for that object instantiation, or just because the application is about to finish. This is particularly useful if you want to execute some code just before the object gets deleted. The syntax is the same as the construct, but with the name destruct instead. Let's modify the fruit class to set the name and color when creating the new fruit object. We have created a construct method that takes two arguments. The first is the name of the fruit and the second is the color of the fruit. And inside of the method, we just set the properties for those values. And now, at the moment of creation of the class, we must specify those arguments. Notice here that by initializing the class variables at the creation of the object, we are giving some values to the class variables by default that we can later retrieve with the getter methods. However, if we did not do that and we just get the variables without initializing them, PHP would complain, saying that the variables are not initialized. That is why defining a constructor where you give default values to the class properties is a very good code practice. There are some cases where we want a class to share its properties and variables to another class, or if you want to have a class that acts as a base or a template for other classes that will extend them and have other custom methods that will differ from the original class. This is what inheritance comes into place. It's a well-established programming principle that allows programmers to extend already defined class quite quickly. The main properties of inheritance is that you can share the properties and methods from the parent class that you inherit from. It can make easier to give a hierarchical structure to your code, and it's very easy to extend and reuse code from other classes. And one of the most important rules is that the accessibility keywords are also affected in the inheritance, meaning that public methods and properties are accessible to child classes, but they are also exposed outside the class. However, protected methods and properties are only accessible from inside of the class and from inside of the child classes, acting as a private keyword but for child classes as well. On the other hand, private methods and properties will exist on the child classes, but they won't be accessible from them. In here we can see that the class vehicle is going to act as a base class for the motorbike, and we can see that those properties and methods are going to get inherited to the class motorbike. And as you can see, they are all public, meaning that they will be accessible from the motorbike class as well as from outside of the vehicle and motorbike classes. To inherit from a class, we just need to specify the extend keyword followed by the name of the class that we want to inherit from. And for accessing the members of the parent class, we just access it as a normal property, just by using the arrow key followed by the name of the property or method. Let's modify the fruit class example to extend from a parent class. In this example, we moved all the generic methods to the parent class food, which will act as a base class for the fruit class. Internally, fruit is getting access to all those methods and variables from the food class. Notice here that the accessibility keywords also affect the inherited classes, meaning that the private properties won't be accessible from the child classes or from outside the class. This will prevent accessing the color and name properties, thus forcing us to use the getter methods in this child method. Let's change the properties to be protected. By doing this, we are giving direct access to the child classes for these properties, meaning that they will still be unaccessible from outside those two classes, but they will be accessible from the class food as well from the class fruit. And we can simply access them by just specifying the name of the property. A useful feature in inheritance that we can use, which is called overriding methods. It is basically the action of replacing a parent method with a child version of that particular method. The rules are that the methods need to share the same function name on both parent and child. They need to have the same accessibility keywords on both, and they need to return the same data type. And the logic will work as the following. If no overriding of that function is defined on the child class, the default call is going to happen on the parent method. However, if there is an overwritten function on the child class, the default method will never be called unless the user specifies it. As you can see here on the class vehicle, we have the default method message. However, in the class motorbike, which extends from vehicle, we have overridden that particular method. That means that the parent method message would not be executed when the message function gets called. Let's change our previous example to show this. The message method in the fruit class is generic enough to be placed on the base class food, and somehow we need to modify the message printed depending on the class that it got called. We can use the overriding feature to do this. We specified the message method on the parent class with a default message printed. However, in the fruit class, we are overriding this method with our custom message. This means that when the fruit message method gets called, it will use the overridden message method instead of the parent method. Now, what if we would like to create a class that has all the generic methods that other classes would use as a base, but we would like to prevent the user to use that class directly? This is what an abstract class is for. It is basically a base class for other classes to extend from, and the main features of abstract classes are that they can be instantiated, they act as an empty template, and they need to hold at least one abstract method. Now, an abstract method is a method that is declared in an abstract class, but it's not defined, meaning that it doesn't have any logic. And this is basically to force the child classes that extend from that abstract class to add some specific logic to that particular function. For defining an abstract class, we just use the abstract keyword in front of the class definition. Then we specify the abstract method that we would like the child classes to define. It uses the same syntax. We just specify the abstract keyword just in front of the function declaration, and instead of having curly brackets, we just have a semicolon at the end without adding any logic to that particular method. And then every class that extends from that abstract class must define code to that particular method. As you can see here, we are overriding the message method and adding some code. Let's modify the previous example to show how to do this. Now, as we saw here, the class food should be abstract because it's not any particular type and it shouldn't have any kind of logic. And because we defined the class to be abstract, we need to specify at least one method to be abstract as well. I believe the message method should be perfect for this case. Now, because we defined the abstract method, every class that extends from the food class must define that method in their implementation. And because we specified that the class food is abstract, we can no longer initialize class food by using the new keyword, because now it's just working as a template for other classes to extend from. Another interesting feature we have with classes is static methods. A static method is a way to call a method of a class without having an instance of it. The limitations are that they don't have access to non-static class methods or properties, and the features is that they can be abstract as well, and they can also be overridden. For declaring a static method, you just specify the static keyword just in front of the function declaration. And for overriding, you just need to have the same exact syntax as the method that you want to override, meaning that they need to share the accessibility keyword, they need to share also now the static keyword, and they need to be called the same, and they need to return the same data type. And for calling the method, you just specify the name of the class, followed by 2 colons and the name of the static method. There is a similar behavior for properties. You can declare a static property, which is a property that will be available without having an instance of the class. The main feature is that for the whole application, the property value will remain the same. And you can define the static property by just using the static keyword in front of the property declaration. And for accessing it, you write down the class name followed by 2 colons followed by the name of the property that you want to access. It's time for a little exercise to practice the concepts that we have learned in this lesson. In this exercise, I want you to create a class that can only have one instance of itself for the whole application lifetime. Or in other words, whenever I try to access or create an instance of that class, I will always receive the same instance, restricting the creation of more than one instance. As you can see here, I have 2 code blocks on different parts of my application, and every time I try to get an instance of that particular class, I should get the same instance. And after that is done, I would like to have a class method that prints a counter and increases it each time we call that method. This way we can know that the counter will share the value between different parts of the code without having to copying and pasting the same class logic over. As a hint, I will say that this exercise will require you to use static methods as well as static properties. If you want to give it a try, pause the video now and come back when you have it, or if you got stuck with the solution. I will explain how to solve this in a couple of seconds. Okay, let's start with the solution of this problem. The first thing that we'll need to do is to declare the class. We will then need to declare a static function that will give us the unique instance of this class. The major challenge of this exercise is to somehow make the class hold the instance of itself for every time we ask for access. We can do this by storing the instance of the class in a static class property. This way, the property will always hold the instance of this class no matter where you are calling it from. And now we will just create a new instance once, the first time that we request the access to the class. Lastly, we need to define the method that will increase the counter and print the count amount. As a bonus, we do not want the user to be able to instantiate this class from anywhere else than from the getInstant method. Therefore, we'll need to set the constructor as private, meaning that only itself can have access to it. And now let's give it a try. In here, I am requesting access to the instance from the getInstant method. The method is static, meaning that I don't need to access it from an instance of the class. This will return an instance of that particular class and then print and increase the counter. After it, I am requesting another instance of the class and printing and increasing the value again. If we did things correctly, we should see the counter to be 1 and then to be 2. A little error that I made is that because we are trying to access an instance that is not already defined, we need to specify that at the beginning the instance is null, meaning that it doesn't have anything at all. And for being able to define a null, we need to specify the question mark at the beginning to specify that this property can be empty. Now, if we try this, we can see that the counter goes to 1 and then to 2. Let's do a little bit of debugging to see what happens. The first thing is that we are trying to get an instance of the class. And if we check here, we can see that the instance at the very beginning is null, meaning that it will go here and create a new instance. And as we can see here now, the instance is not null anymore, and it will return it. After it, we just go and print at the counter, increase the counter to 1, and then print the value. And the second time, we can see that the instance is not null anymore because we instantiated it before. And if we try to access the instance, we can see that the counter is still 1 from the previous call. And if we continue, we can see now that the counter is 2 and it prints the counter. If you didn't notice by now, this class is actually a well-known design pattern called a singleton. It is basically a class that can only have one instance of itself, and it is usually shared across all the application code. And this is the end of today's lesson, and also the last video of this PHP for Beginner series. By now, you should be familiar with most of the programming concepts and have ways of developing basic applications in PHP. If you like, feel free to check out my other advanced PHP lesson that will be useful for website applications and other kind of applications as well. Thank you for staying until the end of this video series. I hope you liked the content and you had as much fun as I did. Please leave a like if you like the content, and I hope I'll see you in another video.